Hey, it is Thursday during tutorial, the last day of the 9 weeks, and no one's in tutoring. So I decided I'm going to start recording the first lesson we'll have when we come back from the 4-day weekend and start our new 9 weeks, which is going to be Chapter 3, Section 4, a review of equations of lines. So if someone comes to tutoring, then I'll split this video into two parts. Here we go. All right. I am going to maybe use this for part for some examples, and I also wanted you all to be aware of it. I saw a couple of people were using it for the last homework assignment, and it's like, oh yeah, this is a great tool. Desmos.com/calculator. In Algebra 1, they're all like trying to get you to not use the calculator because you need to be really good at graphing by the time you get to Algebra 2. And in geometry, you get to practice a little bit more, but it's okay to use tools like that. Alrighty. I also want to review a few things. Last time I wanted to show you different videos. I used the Khan Academy videos and this other guy that teaches geometry. I used part of his video. But then there were a couple things that I wish I would have said. Okay, so I'm going to add those now. And as I've been grading your work, I have been giving you some feedback if it was relevant. So maybe you already know this, but just to re-emphasize that when you have laser pointer, okay. So these are when you just look at a graph, you can see the slope by the way that it is slanted. For example, if I'm always moving from left to right, then this person, if this is a person right here, when I used to teach Algebra 1, I would draw a little girl and I would call her Babs the algebra girl. And she would always enter the scene from left. And right here, she would be going up the hill, so that's called positive slope. Going down the hill is negative slope. Okay, and Babs always loves a thrilling adventure, so she really likes really big slopes. A big slope would be like a more steep slope, so it could be positive or negative. A zero slope, zero, it's horizontal, so that when I would draw the girl going across this slope, she would be yawning and her mouth is a big O, like the number zero. With zero slope, you're only, like if I would go from this point to this point, I did not change in my y direction. I only changed in the x direction. So if I was calculating slope, the numerator would be 0, and 0 divided by any number is 0. You could do that in the calculator to double check. Undefined, and I would draw Babs, and she would be, her hair would be flying going down this big steep slope here, and words would be coming out of her mouth, but I would use like the editing, what is it called when you edit a song? Dang it. But anyway, like I'd put star, exclamation point, like, because the words coming out of her mouth were undefined because she was quite thrilled. But the real reason it's undefined is because if I would go from this point to this point, I did not change my x coordinate at all, only y changed. And so the change in y would have a number, but the change in x would be 0. So in the denominator, you would have a 0 if you were calculating slope. And if you put that in the calculator, like any number divided by 0, you would get error. And that will give you a hint, like, okay, that's the one that has undefined slope. And so this is also from 3.2, right? Slopes of parallel lines. Oh no, those are postulate numbers. These are both from section 3.3. These are just information from the book. But if you have two parallel lines, they are non-vertical lines that have the same slope. Okay, and so if they give you these two examples where the slope is 4 for both line L and M, and they are parallel if and only if they have the same slope. And if they have the same slope, then they're parallel. Okay, and then they also threw line P in here, intersecting both of those lines, a transversal. And this transversal, line P, they show the slope is negative 1/4. If you don't believe it, you could count it down 1/4, down 1/4. And when two lines are perpendicular, their slopes are like that opposite reciprocal of each other that we talked about. And I showed you the video, the Khan Academy video. So 4 and negative 1/4 are 4/1, 1/4, one's positive and one's negative. And the way they defined it in the book was two non-vertical lines are perpendicular if and only if the product of their slopes is -1. Because when you multiply a number by its reciprocal, the product is -1. That's actually like the definition of reciprocal. Alrighty, let's see if I can. Okay, now here's something that I was like, oh, I should have emphasized horizontal and vertical lines. Although, no matter how many times I say it, it just takes a while before a student will just suddenly remember what they look like. Okay, so here is not what they look like, but their slope, a horizontal line. The slope is 0, and the equation only has a y in it. There's no x in the equation of a horizontal line. When you have a vertical line, the slope is undefined, and there's only an x in the equation. There's no y in the equation. Because if you remember y equals mx plus b, if you don't, I'm about to go over it again. But remember when you normally, like most lines that are like all slanty or whatever, it's like y equals 3x plus 5, y equals -1/4, x minus 7. Notice how there's both a y and an x in those equations? Well, in this equation right here, x equals -2, that's an equation, and it doesn't have any y's in it because every single point on this line has a coordinate -2 for x. Look, this point right here, -2, 0. This point right here, -2, 2. This point right here, -2, 4. So all of the x's are -2. That's what that means, okay? And it never touches the y-axis. That's the other reason it doesn't have a y in it, because it's not going to touch the y-axis. Okay, and a horizontal line has a slope of 0, and every point on this line, the y coordinate's -3. Look, this point right here is 1, 2, 3, 3, -3. This point right here, 1, -3. This point, 0, -3. This point right here is, let's use this point, -4, -3. All of them have the same y coordinate. So that's part of why, the reason that it's named that. And this only touches, it only intersects the y-axis. It doesn't intersect the x-axis. It's kind of like the opposite of what you're expecting, right? Because that y-axis goes this way, but in the equation that is horizontal is called y equals whatever number it touches on the y-axis. Alrighty. Hopefully that helps. Those are some common errors from Algebra 1. Now, finding the slope of a line. So this is what you did for homework 5 days ago, 6 days ago, whenever you turned in a 3.3 assignment, maybe longer. You found slopes of lines. And so the slope of this line, now that I've reviewed this, when you look at that, you're like, okay, that the slope is undefined. I don't even need to do the work. But if you did do the work, it would look like this. Change in y, because when you have numbers and you're finding the change between the numbers, you subtract. Change in y divided by change in x. So the two y's are numbers, -3 minus 4, and the two x's are 0. Because this is that vertical line that is on the y-axis itself. And so the slope is -7/0, but that -7 is completely irrelevant. And it's not correct if you leave your answer like that. And on the homework, I think it was like number 20 was undefined. And I didn't count it wrong, but I wrote you a note if you showed your work. I was like, hey, you need to simplify it one more step, like call it undefined. And stay away from calling things no slope, because it's very confusing. Some people think that having a slope of 0 is no slope, and some people think that having a vertical line has no slope. So just don't use that. It's either going to be undefined if it's vertical or 0 if it's horizontal. And guess what? The equation of that line would be y equals 0. I did it. I did the thing. I saw a vertical line, and so I put y in my head. It would be x equals 0, because every point on that line has a coordinate, an x coordinate of 0. Look, 0, 4, 0, -3. The only place it touches the x-axis is at 0. And the same thing with the horizontal line. I'll go faster this time. When you subtract the x's, when you find, I mean the y's, when you find the change in y, you find that the numerator is 0. There's no change in y. And you knew that when you looked at it, it's going to have slope 0. And look, both of them have a y that's -1, and that would be the equation of this line. This line only touches the y-axis at -1. So if they asked you to write the equation, then you would say y equals -1. Okay, and then again, I'm showing you warm-ups that we would have if it was class time. And I'm in chapter 3. Like I said, I'm not having you do warm-ups. If you're watching this before class and you decide to try them, feel free. I have 3 questions, and I have them in the next 3 slides. And this is a little bit different than what I assigned you for homework. This is saying, okay, what is the slope of a line perpendicular to line MN if this is M and this is N? Okay, so let me write with my mouse. So if the slope is change in y, this is how I write change in y, instead of writing y2 minus y1, over change in x. And if I subtract these 2 y's, I like to think of it this way. Instead of actually subtracting them, I like to picture the number line and think like, well, how far apart are -8 and 4? Because that's really what we're doing. If we would graph it, we would just be counting how far is it from -8 to 4. It would be 12 units apart. Okay, so the change in y is going to be 12, and the change in x would be 8. But that's kind of going to be, okay, so anyway, 12 over 8, and that's going to be 12 divided by 4 is 3. Oops, 12 divided by 4 is 3, and then 8 divided by 4 is 2. I'll cheat by doing this. So the slope is 3/2, but I made a big mistake because I didn't take into I only took into consideration how far apart they were. I didn't think about, like, if I was actually graphing it and counting it, was I going down or was I going up? So I guess I better go back and subtract them. -8 minus 4 would give me a -12. And 5 minus -3 would give me a +8. So this would end up having a negative slope. So that's where, what? Did I do it wrong? -8 minus 4 is -12. And 5 minus -3 is 8. Okay, so my slide has a mistake in it. The correct answer should be A. Nice. If you're watching this video and I actually did make a mistake, I'll give you bonus if you can show me what I did wrong, because I don't see my mistake. It's super hard when you're differing in your oh, if you already noticed it, then I commend you. That is the slope of the line. What is the question asking you? Either I'm a really good actor or I actually made a mistake. It says, what is the slope of a line perpendicular to line MN? So that isn't the answer. This is the slope of MN. What I like to do, because you're going to be doing this a bunch in the future. I can't remember what chapter we do this in, but where they're asking, they're giving you a point, and well, in this homework you're going to do it a little bit, but it's going to happen later, where I need to keep track of which line I'm talking about. So sometimes I'll say, okay, so the slope of line MN is -3/2. So what is the slope of the line perpendicular to MN? Oh, I can just put the perpendicular symbol. And the perpendicular slope would be the reciprocal, and it would be positive. So did you fall for it like I did? You do all that work to get the slope, and then that's not even like the answer. This one's the answer. Okay, whoops, I'll take off my pointer. Okay, this one's the answer. That's why that's there. Okay. What is the slope of the line parallel to MN? If this is M and this is N, and are those the same M and N that we did last time? -3/4, 5, -8. So we already know the slope of MN is -3/2. So if we want to know the line parallel to MN, then it's going to be -3/2. Okay. Which graph has slope 0? I don't even need to read the rest of it because there's only one horizontal line. But notice how there's like an infinite number of lines that could have slope 0. Any horizontal line would have slope 0. It's really important that you realize that you need that to graph the line. You need to have like an anchor point, a starting point for where you start counting out the slope. And in this case, you don't have to count the slope. You just need to know where is that horizontal line going to be located on the coordinate plane. And it has to have the point -3, 4, and then you just draw a horizontal line through it. Because there are a couple of problems today where you need to draw some graphs. Okay, so last time we found slopes. Now you're going to write equations of lines given information about a graph. You're also going to solve some problems by writing equations of lines. The two ways, the two forms of equations of lines, there you go. There's the one that you probably remember is the slope-intercept form, this one. That one is like in Algebra 1, they emphasize it so much that y equals mx plus b doesn't shock anybody. I don't even think you might, I hope you don't have bad memories of y equals mx plus b, where m is the slope and b is the y-intercept. The y-intercept is the place where a graph, let me go back to some graph. Like for example, on this graph, it would eventually cross the y-axis. The y-intercept would be a negative number. On this graph, the y-intercept is -1, 2, 3, 4, -4. On this graph, it looks like the y-intercept is like -1/3 or something. I would need more information to know for sure what the y-intercept is. Notice that at this point right here, though, when I get the y-intercept, the x-coordinate is always 0, and then the y coordinate is the y-intercept, and they use the letter lowercase b. Alrighty, back to this. Okay, so y-intercept slope. Now notice this one this form of an equation, the point slope form, it doesn't have y by itself. So a lot of times in geometry, because this is where you first start to use it more, and then by the time you get to Algebra 2, hopefully I've helped you practice enough where this form of an equation feels more comfortable. You don't have to solve for y. You just leave it like that, the way it is, the way that they give it to you here in this example. And notice there's a y and an x, and over here there's a y and an x, and over here there's two numbers. This is the y-intercept and this is the slope. Here there's 3 numbers. The slope is still sort of in front of the x, but then there's going to be a parentheses. And the numbers in here, these are the coordinates of a point that's on the graph. And so this says, if you know the slope m and you know a point on the graph, x1, y1, then you're going to put it in this equation. Notice that it has minus signs in here. Okay, guess what? If you take the slope formula, slope equals change in y, y2, I almost never write it out, but I will for now just to show you something. y2 minus y1 over x2 minus x1. If you have that equation, and can I change the color? Yes, this would be nice to have it color coordinated or color coded. If I decide, because I can, I want to multiply both sides of this equation by x2 minus x1. Oof. On this side and on this side. Why did I want to do that? Because I can. The reason that I wanted to do that is to show you what happens. Okay, when you multiply two fractions, if you're terrible at multiplying fractions, I'll just remind you that if there's something in the denominator, if you have two fractions and there's the same number in both the numerator and the denominator and you're multiplying, then they can cancel. So look, I did that because I wanted to get rid of that fraction. And look what I have left. I have left y2 minus y1 equals, look, I'll write it like this. I'll write it right over here. y2 minus y1 minus y1 equals, where'd the m go? I mean, where'd the 2 go? You'll see. What if I forget to write the 2's? y2 minus y1 equals x2 minus x1, x2 minus x1 times m. I'm just going to write the m in the front because that's, look, spoiler. It's not a spoiler. It's a super secret thing that a lot of times they don't tell you, that this formula, it's literally just the slope formula rearranged. Fun fact. So if I want to write an equation in slope-intercept form of a line with slope 6, so this is m, the 6 is in m, and the y-intercept is given. They gave me a slope and a y-intercept, so that means slope-intercept form is the only one that would make sense to use. It would be the main one that would make sense to use, so you just do it. You're done. Substituting. Okay. If you wanted to graph it though, so what am I graphing? It says write an equation in slope-intercept form of the line with slope 6 and y-intercept of -3, then graph the line. Okay, so if I'm trying to graph the line, y equals 6x minus 3, I'll rewrite it over here, 6x minus 3. This is what I used to tell my Algebra 1 students. This is the reason they use a b for the y-intercept, because when you graph it, you begin with b. All right, so I'm going to go, you remember it's a y-intercept, so the first thing you do is you plot that point right there on the y-axis at -3, and they got it from this. Okay, now I can tell you that I know that this is going to be a steep line with positive slope because I've done this a lot, and also because I can see that the m is the coefficient of x, the 6 is a whole number, and it's positive. So the rise is bigger than the run. So you use the slope, and you have to begin with b, right? So now from there, you go up 6 and over 1, and you put your next point. That's what I meant by an anchor point. If they give you the slope and the y-intercept, your y-intercept is your anchor point, and then you go up and over, as many times as you can fit on your graph. In this case, they could only fit 1. And then you just connect the 2 points, oops, and you got a line. Putting arrows on the end, of course, labeling the line with the equation, of course. Beautiful. Okay, now this is and I assigned you one of those. Okay, I also assigned you one where it says write an equation in point slope form, and it gives you the slope and a point on the line, and then graph it. Okay, so I think there's 2 only where you need to graph. There might be more, I can't remember. Okay, so this is the point slope form. Remember, it's just the slope and the slope formula like rearranged. Y minus y1 here, x minus x1 here. When I substitute the slope in, that part's easy. It's it's not difficult to substitute the x1 and the y1 in there, but it's really easy to make a mistake if you forget about the minus that's already in the equation. So make sure since the x is negative, that when I substitute a negative in here, I'm going to have minus a negative. See? I wouldn't even write this step. I would just write a plus sign right away. But that's what they did. They substituted this x1, y1 in here, and this was m. And seriously, this is the answer. Okay? You don't solve for y. You don't have to. You're done. It has a lot of juicy, amazing information right there by leaving your equation like that, even though you feel like you're not done. All right. Now, so I need to graph it. And it was y minus 8 equals -3/5 times x plus 10. Oh, you know what they're going to do? Oops. They are going to, it was an email. I was making sure I heard a ding that somebody wasn't trying to get into tutoring, and I was ignoring them. I would feel really bad if that was happening. Nope. Okay. They're going to use, instead of me rewriting this whole thing, I'll just trust the PowerPoint because it has it on there. They're going to say like, okay, because if you had this equation and you didn't have this information, you could get this. -10, positive 8 is going to be on the line, and that's going to be your anchor point. Okay. So when you go to graph -10, 8 way up here, And now you need to know how to move. That's what I would tell my Algebra 1 students. And M for slope, I know, why isn't it an S? I would say because M is how the line moves, all right? So from there, you're going to move down 3 and 5 to the right. You could go up 3 and 5 to the left if it was more convenient, but it's not. So they're going to go down 3 and 5 to the right. And I would do it a couple more times just to make sure my line was straight. Boom, there you go. And they labeled it. So beautiful. Okay, so look, if you're writing a line in point slope form, then this wouldn't be a good answer. The slope is 1/3, so all of these have the slope in the right spot. This is a 6, a positive 6, so this is wrong. And this doesn't have, that has a y in the wrong spot, so that's why B is the answer. And this 3 is positive here because the y is negative, and it's y minus y1 equals m times x minus x1. Write an equation in slope-intercept form for a line containing these 2 points. If it doesn't tell you in slope-intercept form, I would just leave it in point-slope form because, look, they're giving you 2 points. From there, you can calculate the slope. I'll just go quickly over that because we already reviewed this a few times. They got the slope is 3/2, and then you just pick one of the 2 points. You either pick 4, 9, or you could pick -2, 0. And you use that for your x1, y1. Well, yes. Okay, I was going to say, because there's more than one way to do this. You could use them to calculate your point slope form, but this is the best way to do this. The book has a different way of getting the equation in slope intercept form, and you can feel free to follow it. I think I have an example later that does it that way. But to me, this one makes the most sense. Now that you calculated the slope, you're going to substitute it in here, and then I picked 4, 9 to substitute here and here. So the slope was 3/2. We put that in here. And then if they make you change it to slope intercept form, now you could distribute 3/2 times x and 3/2 times -4. You can do it in a calculator if you don't like to do that manually, but it would be -6 anyway. And then you add 9 to the other side. Okay, so that's how you would solve for y. That's how you could get the equation in slope intercept form like they asked. Okay, write an equation of the line through these 2 points. And this example I left it, it's like, well, we already know how to do it. You get the slope, and then you pick a point, and then you substitute them in. But wait, what if when you do your first step, the slope is 0? Well, now you know that it's going to be a horizontal line, and a horizontal line is going to have only a y in the equation. I always have to slowly think about it. Okay, it's only going to have a y in the equation because horizontal lines, every point on the line has the same y. And look, these both had the same y coordinate, -2. So that tells you what the equation is. The equation is going to be y equals -2. They only touch the y-axis, so they only have y. Okay, so there's that example. And then I put this in here again just to remind you that x equals -2 for the vertical line because it touches the x-axis at -2. Write an equation in slope-intercept form. Okay, so now that I reviewed or taught you how to use point-slope form, slope-intercept form, special cases of horizontal and vertical lines. Before that, we reviewed how do you calculate slope, how do you graph lines given a point, given a y-intercept, moving along from point to point using the slope. So in geometry, this is something you might probably didn't do in Algebra 1. This is called, it says example 5 on my slide, and in the book, if you want to see the more examples, you go back a couple of pages until you find example 5. And I've assigned you a few of these, 5 of these type of problems, 5, where you don't have to graph, but you do have to do a little bit of algebra manipulations. So this here example said it's giving you an equation, and then you have to figure out what the slope is, and then say like, okay, Now, what do I need to do with the slope? Do I keep it the same? If it says find a parallel line, then you would keep the slope the same. If it says find a perpendicular line, then you have to do the opposite reciprocal, the thing I pretended to do wrong on that first warm-up. And then you have to see, well, where is that line going to be on the coordinate plane? Like, where is it going to, if it's perpendicular, there's an infinite number of lines that are perpendicular to another line. So you have to get like an anchor point, and they'll give you a point. Like here, they're giving you, it has to go through 2, 0. And then you'll be done. So there's like kind of a few steps. So here we go. Oops, doesn't work. All right. So this equation, I didn't read it to you yet. Write an equation in slope-intercept form for a line perpendicular to this line right here, and that goes through the point 2, 0. So here we go. The slope of y equals 1/5 x plus 2 is 1/5, right? Because the slope is the coefficient of x. So the slope of the line perpendicular to it is going to be, okay, so 1/5, if you flip over 1/5, then you get 5/1. And since that's positive, it's going to be negative. So that's going to be your perpendicular slope. Okay, now the mistake that people do is they get that and they're like, cool, I'm done. And they'll write me this. They'll write y equals negative 5x plus 2. And in a second, I'm going to show you the graphs of that. I'm going to graph that for you and show you why that's not the line that's perpendicular to the line y equals 1/5 x plus 2 that passes through 2, 0. Okay, I'll show you that in a little bit. All right, so this is the other way that you can write an equation in slope-intercept form. This is the way they teach you in Algebra 1. They say, okay, start with slope-intercept form, and then substitute in the slope that you know and the point that you know. So that's where they got this from. They use this x and this y here. They used this x, and they put it here, and they use this y, and they put it here, and now they're just going to solve for b. The way I had shown you that is probably new is I would use y minus y1, and so I would have put y minus 0 equals m, which is negative 5, times x minus x1, which would be x minus 2. So if we did it my way, it would have one less step because y is 0, but that's okay. It's good to, it doesn't matter how you get there as long as you're able to get there. So then they solve for b, and they find out that b equals 10. So the answer is that the actual line that's perpendicular to the line y equals 1/5 x plus 2 is y equals negative 5x plus 10. Well, that's not the only line that's perpendicular. I should have worded it better. The line that's perpendicular to the line y equals 1/5 x plus 2 and goes through the point 2, 0 is this line down here, y equals 5x plus 10. Okay, now hang on. I want to pause this real quick. Keep your annotations, no. And I want to show you on Desmos what that looks like. So if you're writing it down, you know, but I'll tell you because I wrote it down. If I wanted to graph the line y equals 1/5 x plus 2. Oh, look what I did. Look what happens if you don't pay attention. It does 1/5 and then it keeps on going until you tell it that it's not a fraction. Acting again. Where am I? So once you type, okay, let's start over. Y equals 1/5. Then what you do is I'm pushing the arrow, I'm like pushing the sideways arrows. So I'm telling Desmos, stop. I don't want anything else in my denominator, okay? So now I'm going to put the x, 1/5 x plus 2. That's more like what you would be expecting, right? Because you know that 1/5 x plus 2 has a y-intercept of 2. And if you go up 1 and over 5, then you can get to another point on the line. Cool. And then you just push enter. And this calculator is free, desmos.com/calculator. Now, I'm going to type in the answer that most people put. Once they figure out, okay, I know that the opposite reciprocal is negative 5 because I do 5/1, negative 5 x. And then they forget that the y-intercept isn't going to be 2 anymore, plus 2. And when I graph it, it even looks good. It's like, oh yeah, that's perpendicular. That's neat. But if you recall, the problem said, find the line perpendicular to y equals 1/5 x plus 2 that goes through the point 0, 2. So the correct answer, if you remember from the PowerPoint that I can go back to in a second, y equals negative 5x. That part was right, but we got a different y-intercept. Remember when we calculated the y-intercept by using the ordered pair? What was it? The ordered pair was 2, 0 for my x and y. Then I ended up getting plus 10 for, look at that. So these two lines look like they're parallel because they are. They both have a slope of negative 5. They're both perpendicular to the purple line, which was the first one I started with, y equals 1/5 x plus 2. But this one actually goes through the point 2, 0, which was what the original problem stated. Let me go back to that PowerPoint, to that particular slide. Back one. There. So it was, oh, here we go. Remember we did these steps and we got this answer. So the equation, and when you do those, you don't have to graph them. But if you have the Desmos calculator, it's easy. And I had some kids turn it in. It was like genius move because they're doing it on their phone. Well, I think they did. I'm assuming if you go to that website on your phone and you type in the calculator, and then you can just do a screenshot and you're like, I graphed it. So smart, so tech savvy. And I think this is my last example. It's just saying if I had multiple choice, look how nice this is. Also, notice what they gave me. They gave me the y-intercept. Okay, it says, let me read the problem first. I'm getting all excited. Write an equation in slope-intercept form for a line perpendicular to this line. So it has to be 3/1 and negative. Actually, C is the only answer that has the right slope. And the reason that the y-intercept is 8 is because it says it has to pass through the point 0, 8. So that is the y-intercept, because if you go over 0 and up 8, you're on the y-axis. Okay, so that's pretty cool. I'm sad that no one came to tutoring, although most of you didn't need to come to tutoring today, but I'm happy that I got to finish recording this for you.